Hey everyone, can you hear me all right?
Yes.
Okay, perfect. So this is going to be the judging room two, just to make sure you all are in the correct rooms. So we're going to start with judging. The first team is going to be, let me check. It is Team 81, Jerry and Andrew. Do we have Team 81 here?
Yeah, I'm here.
Okay, perfect. So just to keep in mind, we have 4 minutes allotted for your presentation, 4 minutes for your questions and answers, and then 2 minutes for the judges to write down their feedback and submit their judging forms or finish their judging for your team. And then we'll start on with the next team. Be mindful of your time, and I will also be keeping track for you for the 4 minutes at each point. So I'll just let you go ahead and get started, and this will also be recorded as well.
Okay, should I start?
Yep, go right ahead.
All right. It's showing my screen, right?
Yes, we can.
Okay, so we're Team 81. We designed a smart table fan device. So the purpose and idea of our design was to combat any humidity and temperature inconsistencies and issues. Living in the on-campus dorms for the past 2 years, I've noticed like a lot of temperature inconsistencies and like humidity problems. Like rooms will just get super humid sometimes for no reason. So we designed a device that will detect the humidity in the room and automatically turn on a fan once a threshold is passed. And depending on how humid the room is, different speeds will be applied to the fan, and an LED will turn on indicating that a threshold has been passed. So the build, we used an Arduino MCU and a breadboard to build our device. So you can see we used just a list of our components that we used. And the process of building it, we first got our humidity sensor to work and print out the humidity and temperature of the room in the console before we added the display, um, where we then coded in a bunch of constants for the humidity thresholds. We decided on 40, 50, and 60%, and we got it to display on the screen. And then we incorporated the DC motor with a fan attachment with the three different rotation speeds. Um, at level one, it'll just be like a kind of the rotations per second will be just you'll barely be able to hear it. It'll be just overall promote like airflow passively. Whereas as you get higher up, when the humidity reading it's higher, the fan will also go quicker to hopefully reduce humidity. And then we also added an on and off button where you can manually toggle the different levels of speed. And you can just turn off the fan if you don't want it on anymore. And then lastly, we added the RGB LED to display a color gradient depending on the temperature and the humidity levels. And this is our kind of like the results where I turned it on in the dorm and it was 22 degrees Celsius or like 70 degrees Fahrenheit. And it was really humid. It was 59%. So the light was on and the fan was at level two, spinning at about 33%. So that's pretty much it. If uh anyone has questions.
So was humidity the only factor you were measuring, or was it temperature too that you were capturing?
Oh yeah, the temp or the sensor will detect the temperature and humidity, and both of those are used in calculating how fast the speed should spin or the fan should spin and whether the light will turn on.
What's the level of customization you have in this device for an individual user? Because some prefer, like, can you customize it to have specific humidity setting, or is it an algorithm that you envision providing
Uh
uh, to the customers?
okay, for now we just like hard coded in like three different humidity thresholds. So typically I think rooms should be at like 40% is considered normal. So anything above 40% will trigger the level one fan speed. Anything above 50% trigger level two, and then 60% for level three. So in the future, we could probably incorporate a way for the users to set their own thresholds, but for now in the code, it's just 3 levels that we coded in as constants.
Yep, and another factor, you mentioned your dorm room. Those rooms are designed based on the amount of volume recirculation. For the specific fan that you're using, do you anticipate requiring 2, 3 units, or you anticipate a single unit to just circulate out 5 times the room volume to actually create an effect? In other words, what's the response time for effecting a change in your experiments?
So we just with decreasing room humidity, especially for just like a dorm room. So I guess we based it off just like a smaller like bedroom sized room. We researched that like just a small table fan should produce enough airflow within the room to normalize the humidity and like keep it so that there's no like you won't feel congested or anything. So our idea was just to keep it compact, and we think it should be able to work with just like in a bedroom with just a simple table fan.
Sure. And then my last question along those lines, because a portion of the rubric is on social impact.
Mhm.
Do you envision using this in a global sense? What have you given any thought to the social impacts of this innovation, or what are your thoughts around that
Um,
beyond comfort?
I guess it could be an alternative to like just having a thermostat in your room. Maybe if we could incorporate a type of way to also implement air conditioning, maybe you could be able to control both the air temperature along with humidity, since sometimes the temperatures in the dorms will be like perfectly fine, but it'll just be super humid, which will cause like a lot of discomfort and like it'll feel like really uncomfortable. So maybe we could find a way to, if we can incorporate both, I think it could have a greater or like a global impact that way.
Yeah, thanks.
I had a quick question. So is this device like 1-to-1 mapping? Like, I mean, it would work with just one fan, or could you integrate multiple fans to uh, this, and this can control?
Uh, for our breadboard, we were like, there's not like we might have been able to add maybe another fan, but the space was an issue. If we had like a bigger breadboard, you could definitely add multiple fans to this, I think.
Got it. Thank you.
Broadly speaking, do you envision your innovation to be restricted to students in a dorm room, or what's your client profile that you're looking at?
Uh, I guess we came up with the idea with dorm rooms in mind, but it could definitely expand to just like being kept in like your like a bedroom in a house or like just like any smaller scale room, since we wanted the design to be super compact, something you could just put like on like a table or like a shelf. So I think it could definitely be usable for not just dorm rooms, but just like any small living space in general.
Hi, Jerry. I don't know if I saw a user interface template, but if you envision one, could you kind of walk us through what that would look like?
Yeah, so um I think it would just be something similar to like the device used to set your air conditioning. You could like set your different thresholds through maybe like a screen with like I guess 2 buttons to increase or decrease each threshold. And then I don't know, it would just be really simple. I think for ours it was just we coded in the constants and we loaded it up to the MCU. But if we had to implement the interface, it would just be a small display with like a few buttons where you could change the temperature, humidity, set the whatever thresholds you want.
Thank you.
All right, if there are no more questions, judges, please fill out the forms, and then team 78, please be ready to present your project. Judges, take 2 minutes, and then we'll be starting on the next one. Thanks.
Thank you, Jerry and Andrew.
Yep, thank you.
Oh, also, one thing I forgot to mention, if you have finished presenting your project, you are free to leave the Zoom if you are if needed. Okay, judges, please wrap up your or put down your finishing thoughts, and we'll get started with the next presentation. Team 78.
Okay, so we are UCT, also known as the Underwater Ceramic Technicians, and our project was on automatic blinds. So the problem, opening and closing blinds is a very menial task which needs to be done very often, and people usually open them in the mornings and close them at night. So as a team, we asked the question, what is a possible solution to this problem?
So our solution was automatic blinds opening and closing, filled by an iron remote and stepper motor. So the user can interface with it with a power button to close the blinds, and a plus or minus button to close it. And so how it works is the beads interface into the chain drive at the end of the loop, shown in the picture on the right. And then the beads are moved by the stepper motor, which interfaces with the chain drive.
So for the creative process, we had an initial design which had the chain being fed into two smaller motors that spun in opposite directions, comparable to that of an automatic baseball pitching machine. However, the torque produced was insufficient to pull the chain, so the design was improved through the use of a single, more powerful stepper motor. In addition to the new motor, a custom 3D printed wheel was also commissioned that had indents for the beads of the chain to sit in. Here is a picture of one of the motors from the initial prototype design.
So this is a circuitry near the final product. And so as you can see, on the left is the stepper motor with the chain drive, and it's controlled by the motor driver on the breadboard. And then we also have the IR sensor, like right above it, if you can see in the picture, in the middle of the breadboard, to be controlled by the remote. Yeah. So here we have a video demonstrating the So for the purposes of this video, the prototype, we're just in the future we want to build a base for it. As you can see at the top, it was. So with future work, we want to transfer ownership to create an community laptop. So future work will resolve this. It was just a little finicky at the end. Always. Another problem was with our 3D printed chainring. The beads
Excuse me, Elijah, you're coming through very muffled.
Unfortunately, I can try to talk more clearly, but I'm not sure if there's any difference.
Yeah, I can barely hear you.
One second.
It sounded better there, so.
Okay. So with the beads, they often slide off the chain drive.
Maybe check your connection.
Okay, we started to talk through. Does it sound better over?
Sounded a little better, yeah.
Sound better now?
Uh-huh.
Oh, sorry. Okay, we can hear you. Wait, is this better?
Yeah, that sounds better.
Okay. So, with the 3D printed chain drive that we had, sometimes the beads would fall out. So maybe just making deeper grooves and they'd be less likely to fall out would be beneficial. Adding additional ways to control the blinds, such as through utilizing a photoresistor to sense when it is day or night, or a timed-based control, so that way it would go off at the same time every day. And then once a more functional prototype is complete, we want to create a base that anchors the motor to the wall. That's all. Thank you.
All right, judges, you have 4 minutes to answer or to ask all of your questions, and then we'll move on to the actual judging. Thanks.
Good presentation, guys. How do you distinguish yourself from existing smart blind solutions on the market?
So with existing power blinds, they're kind of built into the blinds, but with our design, you can really implement it with any blinds. So for the example of like as a college student in a dorm room, we wouldn't be able to modify the property of the college that isn't ours, but we'd be able to add this motor to the wall, and then it could be like an add-on to the current blind.
How long would it take to set up?
Not long at all. You just so with the pulley, you just put the pulley at the bottom of your blinds, and then so long as the string is taut, it'll work. Yeah, it'd be similar to like a command hook, like just putting it on the wall.
Okay. I guess why should I spend money on this when, the consequence of forgetting to adjust the blinds is not very much?
I mean, this isn't a really like high stakes thing. It's just a
Yeah,
convenience.
so I guess that's my question. Like, I feel like I would rather just use the money for something else. That sounds a little harsh, I realize, but
It wouldn't be too expensive. I mean, it's just the main component is just a stepper motor. It's maybe like
okay.
$10 or $15, and then you can integrate it to whatever
whatever blinds you have, and then you can save
Okay,
it.
okay.
Do you guys measure the impact of like energy savings by doing what this process is going to take care of? Like, is there any energy savings related to this?
I mean, that could be energy savings. I mean,
There's the potential of if you set it on a timer and automatically open it when there's daylight, then you'll be saving electricity from actual lights that you'd have to turn on.
Thank you.
So I see this as a alternative for accessibility for folks that may be unable to operate blinds, or maybe they're just away from their area to adjust it. How would the is this to be running through like a smartphone application? Is that the goal here?
With the current implementation, we just had a remote, but yeah, we would love to implement it with a smartphone design. And you're absolutely right. There are, if you have a disability that maybe makes it so that way you can't reach out for your blinds and pull them down, or if the blinds are in a spot where the window's too high due to your height, then this would be very beneficial.
Are there any remaining questions?
Are there any, one last question would be, what safety challenges do you see with this specific device, or what sort of legal liability would you anticipate as you look to bring this into markets?
the only thing I could think of is with an exposed like chain drive with the stepper motor, there could be like your finger stuck in it or something. So we could, like, if this was an actual product, we could 3D print like a cover, like it wouldn't just be exposed. Like there, you could have like a lid to open and close it.
All right, if there are no more questions, we can go ahead and start with the judging process. Judges, please take 2 minutes to go ahead and write down your feedback, and we'll get started with the next team, Team 23.
Hey Shri, this is a question for you in general. Like, how long the teams have had to complete these projects?
Yep, so not judging. The teams have had 24 hours starting from about 11 a.m. yesterday to create these projects and submit them. So yeah, 24 hours.
Okay, that makes
Yep.
that's perspective. Thank you.
Yep, no problem. All right, judges, please get your final thoughts down and we can go ahead and start with the next presentation. 23, you have 4 minutes starting in now.
All right. Well, So my name is Eli.
I'm Katya,
I'm Leon.
I'm Andy.
and we made a ping pong player. Its balls back at an opposing player, and it's a smaller version of what a potential model would be like. And how it works is it accepts user input to determine when to hit the ball.
In terms of our design process, on the first day, we started to plan out all of the components that we needed and what we want for our final build. Afterwards, we took the time to code out the Arduino specific code for what we wanted to use. And the night of, we built the hardware frame for the actual product.
According to the technical aspects of the project, the components that we use consist of an Arduino Mega 2560 microcontroller, a breadboard, a stepper motor driver, joystick module, and multiple female to male and regular jumper wires. So we use a joystick to take vertical input and swing the player up. When the joystick is pushed upwards, the stepper motor will swing upwards, and when the joystick is pushed downward, the stepper motor will swing downward. We make use of built-in Arduino libraries and uploaded Arduino tutorials on the SunFounder website for interfacing between the joystick and motor and understanding how to connect these components to the microcontroller and breadboard.
In terms of the unique factor and the impact of our product, we think that it's very obviously a leisure product that can be used for entertainment. And as is, it has some charm in its unfinished state.
All right, and as for like what we originally wanted versus what we actually got in the end, so we really wanted to have basically like a track to move across for an XY axis, but with our time and part limitations, that had to be scrapped. So we ended up just having the player rotate and hit the balls as they come to him. And like we just didn't have enough like stepper drivers to really make all the tracks happen. And another kind of big issue was with the speed of the stepper motors, because our player rotates rather slowly as of right now. So maybe if we were to do it in the future, we could find either faster stepper motors, or just some way to rotate him a bit faster to make the hitting motion a bit more fluid. And then here's our demo video real quick. All right. And I believe that is it for our presentation.
All right, judges, you have 4 minutes to ask questions. Thank you for that presentation. 4 minutes starting now.
Yeah, so what would your options be? Like off the shelf if you were, I guess, serious about ping pong and you wanted to practice all the time, didn't always have a partner to practice with.
Like
What
as
getting
of
better?
like, are we talking like as of like right now, what could I walk into the store and buy or like order off Amazon?
Or anywhere, yeah.
Yeah, so like yes, like mostly there's just like kind of serving machines, like a like baseball pitcher at you. It kind of just shoots it at you. There's nothing that really hits it back at you. There's
interactive as what we have.
yeah, there's maybe like walls that you can hit against, but that can only do so much. We were hoping to have something that moves around the table and tries to hit it back at you instead of just bouncing back at you.
So as to practice
Yeah, because I don't think I even remember seeing anything ever like that. So I was kind of curious if you guys do anything else.
Yeah,
I like
that's
I mean, you're allowing introverts to play ping pong. I mean,
yeah, no, that's been one of my big issues. So
But that's my question. So
okay.
Just curious, with the recent craze of like pickleball, do you see this fitting that area or niche?
Yeah, like I could honestly see this like whole concept applying to lots of different sports, especially stuff like tennis, pickleball, and of course ping pong, what we designed it for. Just basically anything that you hit across a like net or anything, or maybe even volleyball if you had to like scale it up. That would be pretty difficult, large scale, but it might be able to be used for like college team sports if you somehow involve like AI and some like some like yeah, and some like camera tracking of the balls, so it would just keep on coming back at them, and I could see it like, and obviously this is a rough prototype, but if it got developed, I feel like it could really like change how practices work.
A side question, and a really great concept and a niche area. If you think about disability, a common theme that's pushed these days is the ability to code the same feature in a VR, for example, like Oculus or HoloLens.
Uh-huh.
How do you compete against that?
Oh,
You don't get as much of a tactical response in VR, in my opinion. That technology might change soon, but personally, as it stands, I don't see it being as effective because while you are still getting a similar kind of practice, there a VR rig cannot fully substitute as it stands the feeling of actually playing a racket sport against some human, or in our case, some sort of robot.
Yeah.
What's this team's name again?
Tim's Tots.
Okay, thank you.
Yeah.
All right, if there are no more questions, then we can start with the judging. For the next 2 minutes, please write down your thoughts, and we'll get started with the next team. I believe that's team 104. All right, judges, please wrap up your finishing thoughts and we can get started with the next presentation, team 104. You have 4 minutes for presenting, starting in whenever you guys share. Team 104, are you able to share your screen?
Yeah, sorry, 1 sec.
No problem.
I think it's being weird.
Can you see my screen?
Yep, you're good to go.
Okay, sorry about that. So our project was a color matching LED game. So a description of it was that the object of the game is to use a joystick to select colors and their brightness levels from 1 to 10 to match a displayed randomized RGB LED. So it's composed of a joystick and then several LEDs, and the user can use the joystick to increase the brightness levels of each color. So move the joystick left for red, up for green, and right for blue. And then that lights up a LED of that color and also increases the brightness of an RGB LED as like a comparison to the color that you're guessing. And then once the player is confident with their guess, they can lock in their answer. And then if any of the colors have the correct brightness level, that LED is lit up at the end. And then the correct answer is also displayed on a monitor as well.
Okay, and the purpose? Well, the game had a simple design and easy to use controls since it was just a joystick. So we were hoping that it would be able to be played by almost anyone and it would benefit their motor and cognitive skills. So for example, like trying to guess the combination of red, blue, and green that's being displayed on the RGB LED allows the user to exercise. Okay, sorry, I thought the mic wasn't on. Allows the user to exercise their reasoning and color distinction skills. And in the process of like choosing the color with the joystick, it can enhance their hand-eye coordination. So this can like help a person that's struggling with color and motor skills or just wants to have a fun time with the game trying to guess the color.
Oh, sorry, I don't know why it's like that. Let me put it back up.
So you can see if you move it up, it's green. To the right, it'll be blue. To the left, it'll be red. And basically it's 0 to 10, like the max amount that each color can be like combined on the LED. So I guess there's really 1,000 possible combinations, which might like add to the difficulty of the game. And the user has to guess it, and then like at the end, like which color you guess the right amount of combination, it'll light up at the end, and you click the joystick for like you to log in the answer once you believe that you have the right combination.
And that's it for our presentation.
All right, judges, please take 4 minutes to ask your questions and then we'll proceed on to the judging period.
Team, if you had to scale this project and if you had more time, what do you think the next steps would be?
Our
Um,
future, oh, sorry. Our future ideas was to implement like a multiplayer mode, so having two players be able to use their own separate joysticks to like battle off against each other to see who can guess the closest color. And then also implementing some sort of display to keep track of the game, maybe making the game loop a couple of times.
And also, I believe allowing the user to choose a difficulty setting, since 1,000 like possible combinations might be a little too difficult for someone's taste. So like maybe if there's like 100 possible combinations or even something lower.
Thank you, team. Great job.
You mentioned that this could be a tool to helping those with motor skills problems. Could you expand on that idea a little more?
Yeah, so I believe that like if like you have poor, or I guess like not developed enough like hand skills, like or even like cognitive skills to like detect like color properly, you can practice that like with like moving your hands, like the beginning like slow steps of like developing like fully functioning motor skills.
Thank you.
So, well, the follow-up to that would be, what is the market right there for those type of games, and how do you differentiate yourself from the existing market?
I think there already exists like a pretty popular board game that's centered around like guessing colors and being able to do that. But from what I know, none of them actually have like the visualization or like the actual joystick. It's just like printed in front of you. So this allows for like more of a user experience in comparison to other products.
Thank you.
Are there any other questions? If not, we can proceed to the judging period. And judges, please take 2 minutes to write down your feedback, and then we can start on with the next team.
Hey, can you hear us?
Yep.
Awesome. Do we present now or should we wait for judging to finish?
Please wait for judging to finish. That'll be done in about 2 minutes.
Cool. Just let me know.
Yep, sounds good.
Do we have the team RJA mix? I think they were in between.
Yeah, I think they weren't in the Zoom from what I could tell. So I decided to move on and go to the next team. If they do happen to show up within the remaining time that we have, we can definitely proceed with their presentation as well.
Thank you.
Yep. All right, judges, please write down your finishing thoughts, and then we can go ahead and get started with the next team, team 53. Team 53, are you ready to start?
Yeah, we're ready.
All right, go ahead and share your screen.
Cool. Can you guys see this?
Yep.
Awesome. So we are Team Double Stuff, and we made a product called Heads Up, which is a wearable technology hat that allows you to detect if someone is approaching from behind to avoid potential collisions, and it's designed for pedestrian safety. We have a demo video for you. If you guys can't hear it, just let me know, but I don't think this part is out yet, right?
Yep, no audio.
Heads Up at work. Or can you guys not hear this?
We can't. You'll have to share audio when you do share screen.
Gotcha. How do I do that? Do you guys know how to do that? You know what? That's fine. We'll just do some commentary over it. That's all good. Share computer sound. Okay. Let's try this again.
Here is Heads Up at work. Here is Heads Up at work. As you can see, when someone approaches the hat from behind, the phone makes a noise and sends a notification. We also have a feature in this hat where it detects when someone's coming from the left, right, or directly from behind. So when you approach from the left, it says, "Scooter alert, someone approaching from the left." If you approach from the right, there's an alert saying someone's approaching from the right. It says, "Threat approaching from all over."
All right. Did you guys catch that?
Yep.
Okay, great. Awesome. Glad to hear it. So here's a summary of the whole project. That the main purpose and the problem that we were trying to solve is that campus is littered with easily accessible scooters that can collide and endanger the lives of students on campus who are not paying attention, have AirPods in, oblivious to their surroundings. And these scooters can come in from 15 miles an hour racing and narrowly miss someone, and there's no warning. So we decided to build a solution. And the main purpose behind this was for pedestrian safety. So in a world of distracted and oblivious scooter drivers, it's pretty unsafe for pedestrians to walk up. And to increase this safety and pedestrian awareness, this hat, Heads Up, will alert pedestrians through Bluetooth and this device that is wearable technology when an on-fast approaching scooter person is approaching. And this is how it works. So there's 2 ultrasonic sensors in the back, as you may have seen in the video, and they each point slightly out in one direction. So this will allow us to determine if the threat is approaching from the left or from the right. And when it becomes too close to the user, the ultrasonic sensors will fire a serial communication through Bluetooth to the Android app that we built in Java in Kotlin. And
just a quick reminder, we're about at the 4-minute period. Please give your finishing thoughts and then we can proceed with the questions and answers.
You got it. So it just notifies you through the Android API through notifications on your phone. To improve, we would use better sensors that are not included in the kit to see even further and improve the algorithm. But yeah, that pretty much covers it.
So thank you for your presentation. Judges, you can go ahead and ask your questions now.
Good presentation. what are some limitations, or the other way to ask it would be, what is the probability of getting false alarms on the app? You probably cannot use this in New York City, or can you?
That's a fair question. These sensors that we used are limited to only like maybe 4 or 5 meters max. So it would, in a dense area, yes, you would not need to wear this technology, but also in that regard, there would be nothing, there would be no scooter threat or someone approaching behind you in a dense area. So it would not be necessary in New York City when you're surrounded by people and you're protected in the herd. This is more of if you're walking alone at night and something is approaching you and you got to be take necessary precautions to be a bit safer.
Thank you.
Oh, I
Just
guess
follow-up question to that. A really cool idea. So have you thought about some also kind of based on the signals that you receive, and if there's a false alarm, just training based on that, like can improve your sensing
Yeah.
technology?
The algorithm on the Arduino will calculate the average of many sensor pulses. It's not just going to fire if a fly flies in front of the ultrasonic sensor. It has to be a consistent object that's nearby after a period of long distance range of empty space. So it's only if there's an object that's consistently nearby that person after a period of open space will it actually signal the Arduino to fire.
So my question is, why? I guess you focused on scooters for a 24-hour project. But, I guess I also could see this being used as just for personal safety in general. And yeah, but along with that, I feel like what do you think are some other ways that you could notify the user other than through a smartphone? Because they may not be looking at it all the time, and it does take, about 2 seconds to get out your phone and look at your notification. So,
Yes.
I
So
just wonder
another
if you thought about that.
we have another iterate if we had a chance to do another iteration of this design, we would probably do some sort of like a wearable wristband that would buzz. Something along that, something like a haptic notification rather than a sound notification going through Bluetooth or headphones or something along those lines.
And also another assumption was that the phone itself would make haptics. And also like a lot of people have smartwatches that send haptics to your wrist whenever your phone gets a notification. So that was kind of our idea. It also sends a sound where it's not just a notification. There's also a separate sound coming from the app. So if you're wearing AirPods, the sound would override
I see.
whatever
I
music
see.
you're listening to.
Okay, I might have missed that, but yeah. Thank you.
Yeah.
Actually, I had another question. Is there anything like this product on the market? Because like I'm surprised nobody's really done this yet, either in the commercial space or like government space or like I just wondered if you researched that at all when making this.
As far as we're aware, we haven't seen any products. I don't know about you guys though.
There were some projects where people tried to make a similar idea for social distancing during COVID, but nothing that applies to what we did as like specific use that we did.
Okay, that concludes our questioning period. So now, judges, you can go ahead and start filling out your forms, and then we will proceed with the next team, Team 127, after that break. All right, judges, please wrap up on your forms, and then we can go ahead and proceed with the next team, team 127. All right, team 127, you can go ahead and share your screen, and then I'll start when you guys are starting.
Can you see my screen?
Yep, you're good to go.
Okay. I was trying to share audio, but it wanted me to close out of Zoom again, so I just didn't. So you won't be able to hear my video.
It's no problem.
We are the laser beam tripwire, and this is what our project was. In our project, we use various components as like a laser and a buzzer and the MCU Arduino board. And our main purpose was to create some kind of like safety device that you can kind of like put in your dorm room, because you know you can't just like put a Ring doorbell on your dorm room. That would look kind of weird. Just some kind of like personal safety, especially if you know you're living in a pretty big building close to the street. You know, a lot of people are frequent in and out, and you can only do so much to stop like people tailgating into the building that don't live there. Here's a video demonstration of how it works.
So the project works by having this laser, and when we cut the connection, the photoresistor, which is right here.
So we used a photoresistor to kind of be able to tell when the laser cuts the connection. And from that, we connected a buzzer, which will play a sound, and an LED that will turn off. And this is the code we used. We kind of adjusted the threshold on the photoresistor to tell when when it goes out and when it's there. And that's all.
All right, judges, go ahead and ask your questions. You have 4 minutes. Thanks.
So what exactly, how do you intend on this being used? Like if you install this on the entrance of a building, for instance, like you mentioned before.
So this would mainly be like at the entrance of your own personal room and not the dorm building, because the dorm building has its own security. But you know, like if you're going to the bathroom, if you're stepping out for a little bit to like put your laundry in and you want to leave your door open, then like you like ideally like we'd expand this to have it so that the buzzer, you could always hear the sound like with you. So it'd be like through an app or on your phone. That way you can know if like something or someone enters while you're away.
Okay, so I guess my immediate thought is I guess why would you leave your door open if you think there's a possibility of someone walking in, you know, without your permission? I mean, I guess I heard what you said, but you know, especially if you're living in a dorm, you know, maybe it's.
I mean, like
I
at
feel
some
like there's
point
also
you can only
about.
control like sorry, go ahead.
Yeah, because once someone enters your apartment, if they have, you know, malintention, I feel like there's not much that the device can do for you at that point. I mean, I guess you know not to enter the room if there's an immediate threat, but I don't know, that's just my thoughts, but maybe you had more to it.
So last year I was in a dorm with 9 other girls, and you know, like I can only control my actions as much as I do. And like so when I leave the room, I'll lock the door. But like other people can leave the door open, do whatever they want. And if it's like
Okay.
like kind of like a pretty big night where lots of things are happening around campus, like anyone can come and enter your room and you wouldn't even know. And like I wouldn't want to enter my room if I knew there was an intruder in there.
Okay, but then I guess that there's another question. Like, how do you know what exactly to do with the response from your device? Like how do you tell whether it's a roommate or it's an intruder?
So we could distinguish by kind of like if everyone has a specific signal on their phone, so when they enter the room, you
Okay.
can determine what's a safe signal and what's an unsafe signal, and only people who live in the room will have obviously those signals on their phone, so they won't set off the wire.
So you'd have to set that up beforehand, that what you mean, or
Yeah, when you're
Okay.
setting up the device.
Okay.
The follow-up
Thank you for
question
the
to
clarification.
oh sorry, the follow-up question to that would be, how do you distinguish yourself from current market products? For example, I'm assuming you will be significantly cheaper than a Ring camera system. Is that right?
Yeah. So because it's not as complex, it only really has very basic features. It is probably more affordable for the demographic that we're kind of going for. Like if you just want to secure one room or a single area in your room.
Thank you.
All right, we've come to the end of the questioning period. Judges, please take 2 minutes and write down your thoughts, and then we will proceed to the next presentation. Team 1, the Cool Beans, I believe. All right, judges, please write down your final thoughts, and then we'll proceed with the next team, Team 1. Team 1, go ahead and start whenever you're ready.
You able to hear us?
Yep.
All right, so for Make Ohio this year, we decided to build the Bioemergency Aid Navigator as the Cool Beans. This is the team. We have Garrett here, Sawyer, Michael, and me, left to right. Garrett's third-year industrial systems engineering major, and the rest of us are all computer science and engineering majors. So the goal of the Bean, or the Bioemergency Aid Navigator, is to help identify injured and or lost individuals and deliver them a first aid kit or supplies using a drone and other systems. So like, for example, if forest fire is going on, we do identify or find individuals that are maybe lost inside the forest. This would help out, or if someone got injured, delivering them that type of supplies.
We constructed our project starting with a DJI Mavic Mini drone, and then we 3D printed a carrier and a locking mechanism to carry payload. The computer that powered the servo that opened and closed the payload carrier was an ESP32S3, and it connected via Wi-Fi through Adafruit IO, so we could control the open and close all in one program. And the camera on the drone fed data into our program through YOLO V8 to do image recognition.
This will be the drone feed. So you can see it goes up there, and I have the model trained to only display certain things when it's really confident in something. So those numbers you're seeing is the confidence level the model has, so it knows that's definitely a person. And our idea would be to drop off or let someone know when they find a person, and then give feedback to allow them to drop the device if the person is in need of it. This next video is the person actually receiving. You can see the drone make a drop off. So it'll fly up and confirm that the person needs help, and then he's waving in this, we're not able to see his hand too well, and we know he needs it, so the drone goes ahead and drops it right there. It's a small container. We were able to put some medical supplies in there. We got a couple band-aids in there for him, and he'll show you what he got. And the drone is able to fly off.
Oh, yeah. And then this is our dashboard for the drone, which pretty much shows a few different features and with the video play. This is the live drone feed on the dashboard of just recording the camera of the drone. So as you can see, it flies over, and then this one just shows the actual feed, not the actual detection. And then, yep, it just flies away. And then the other, oh, go back. There we go. And I have like a photo. Where'd it go?
Back point.
Oh,
That
right
one.
there. Gotcha. Okay. Yeah. So, so we have the live drone feed, and on the right side, we have the amount of items that the drone is holding. So pretty much whenever the drone is sent out, we can let the dashboard know, or let the drone and recognize what the drone knows and say how much items each or what the drone has in like the drop-off system. And we also have a coordinate location system, so it'll actually keep track of where the drone is actually going and where it is in the field. And on the final left side, we want to add, when we do more drones, we want to have a dashboard for each different types of drones. For this is drone one, and when we have more, we'll do multiple.
So yeah, so some current next steps that we're thinking of with this project, obviously, like Michael was mentioning with the dashboard, increasing one drone to a fleet, or having some kind of just multiple drones that you can access and use. Automatic flying for the drones, so that way the user doesn't, or someone doesn't have to fly them. Different specifically targeted first aid materials based on different scenarios. Obviously, you don't need to deliver certain things if it's not applicable to the person that you may be trying to find. Fine tuning of the models with the YOLO V8, and then obviously better drones, better materials, and a better drop system. We were not able to drop a huge payload, so we'd like to have a balance between cost, efficiency, and weight in the future. And that'll be it.
Thank you.
Awesome. Judges, we can now transition into the Q&A, and go ahead and ask your questions. You have 4 minutes.
How do you distinguish yourself from the existing market competition?
A lot of the existing market competition is really expensive. There's a lot of upfront costs. We kind of designed this with an idea of it staying open source. We are trying to let other people see the design of it. And then if we wanted to enter the market, we would use a lot of new techniques to do stuff. So commonplace currently is a plane would be used, like an RC plane, drop things off. I know Google has been invested in a couple, but ours is a drone. And if you take a look at some of the newer models coming out of some Chinese research universities, they have actually developed things for drones to detect like under tree or under overgrowth navigation automatically. So with a drone, instead of an RC plane, we would be able to actually navigate and go search for people in a denser forest area instead of just sitting on top of it.
Hi guys, could you kind of expand if this is something that works with public safety and how this would work with like FAA and Part 107 regulations?
I'm not familiar with the FAA. This drone currently though is underweight, so it doesn't have to be regulated with the FAA, but our idea would kind of be to give it to a government organization and have them run it. So we Firewatch, a lot of the teams up there, we think would be able to get a lot of use out of it. So I think they'd be able to kind of tie it off with the FAA.
Good. Hey guys, I had a quick question. So how do you like I heard someone saying that you would detect that the person needs help or not. Do you have any algorithm for that, or is it more on the confidence score that
So
you
we're currently just using a basic YOLO V8 model. We would like to train it though, once we get, so it's really easy to identify a person, but being able to identify an injury would be a lot harder. So we'd like to have a second model run after we get to the person, get up close with them. And if we're able to detect like that leg is bent at a wrong angle, so it's probably broken, or we detect a lot of scrapes, bruises, there's a fire next to them, something like that going on. So implementing a second layer, I think would be really beneficial to it.
We'd also like to add in a microphone and speaker for two-way communication between the operator of the drone and the person in need of help, so they can kind of have a level of communication if they're able to say, you know, yes, I need help. No, I don't need help. Or, you know, there's more people here, or I can, you know, someone on the scene who knows the situation better, they can interact with them via the drone, especially if it's a dangerous area where there's no access. Recently in an area where I live, close to me, there was a tornado in the last couple of weeks, and the sheriff mentioned they were on an island at Indian Lake, mentioned how difficult it was to get there for search and rescue. So something like this would be good to be able to like get on that island, and they could talk to the people, even if not to use the full capabilities of dropping off payloads, but just to communicate in a natural disaster or an emergency situation with somebody.
Oh, makes sense. Thank you.
Hi team. Very cool idea and very cool demo. Thank you for sharing. I have a question on whether or not you guys would be interested in having a like multiple kind of sensor setup where it's not just the camera identifying people. You maybe have like some kind of UI, the IV sensor or something like that to see people, like maybe if the environment's kind of an obscure condition, like in a fire, very smoky, or if it's very rainy or snowy, where the camera might not suffice, or if it's very foggy outside. Do you guys would you guys consider something like that for the drone as like in the future?
Oh, definitely. So we could use all kinds of different systems to detect what's going on. Camera is very limited. We even had an issue with it today where like the gimbal got messed up. So we wouldn't want to completely rely on that in a lot of these situations. Something like a FLIR camera to be able to see a heat map of your area, that kind of thing would be really useful, I think.
Yeah, agreed. Thank you.
Thank you.
All right. That does finish up the time we have allotted for questions. Judges, please finish up with your forms. I don't see the other team anywhere, so I think this is our last team. Thank you once again for doing this and judging all these amazing projects. We really appreciate it.
Thank you, everyone.
Thanks.
Thank you.
Thank you.
Thank you. Thanks.
So Sri, what are the next steps? Do we go to the main room or
So I believe there'll be more information sent out in the judging Discord. Please look and have an eye out for that. I can also find a little bit more information to as well and send that out in that same Discord. I think there will be a person that you can send your rubrics to, and then we'll get everything sorted out from there. So We'll send out a message in the Discord for all the general judges that aren't part of the challenges.
Thank you.
Oh, was that the last group? Is there any more?
Yeah, I do believe there was one group that wasn't able to make or didn't show up in the Zoom. I think that was team RJA Make 47. They weren't
Okay.
ever in the Zoom, so I don't think we are. They might not have joined the correct one. I'm not sure, but I think that the Cool Beans was our last team, so that should be fine.
Okay.
we
Yeah, I might have to go
hosting?
somewhere, so am I good to?
All right, thank you. Please keep an eye out on the Discord for where to send your rubrics and everything like that. And once again, thank you for all for volunteering to be judges for us today.
Thank you.
Thank you.
You.